Hi, everybody. Mr. Biscayewitz. I'm the engineering teacher at Hayfield Secondary School. Everybody calls me Mr. B. This is a demonstration video on how to build this particular rocket. This kit, we use a complete kit. It supplies everything that we need to build this, no tools, but all the materials. This is from Pitsco, and this is the Strato blaster kit, all right? It's a 3-fin rocket design, and we do not deviate from the design of this kit. You can if you want, but for to get a 30 students in a classroom to build this rocket in a short amount of time, we stick with the standard design, and it will look something like this. I have an unpainted design I want to show you, because then the individual parts that we're going to be building are a lot more obvious, all right? So here is an unpainted rocket. You do not have to paint the rockets, of course, but we do. Kids really enjoy that. So we have the bottle itself, the water bottle itself, okay? That's part of the kit. We have fin material. It looks like this that we make our fins of. Body tube, transition cone, all right? And recovery system is a simple cup and ping ball recovery system. I've been building this design for years. I highly recommend it. It's very reliable and very straightforward to build for the students. And you will see some of the tools that I use along the way. It's pretty simple stuff, except for one, but Pitsco has a way to help you out there too. Anyway, let's get started. And we are going to start with the fins. I'm going to be tilting the camera down because, like I said, this is a demonstration video. And so what you see here, and let me flip it around so it makes more sense from your perspective. Come on, click. There we go. All right. This is a fin design worksheet. I created this fin design worksheet. And the reason I created it is this is the fin material, okay? And students need to get 3 fins out of this material. And so I gave them a box to draw their fin design in, and then they use that as a template and transfer that design onto this fin material, of course, 3 times. And this box is 3 times the size. You get why I'm doing that. So if they were to draw a fin that was a lot bigger, they couldn't get 3 fins out of this material, all right? So that's why I do that, all right? So any fin design they want, however, I do encourage students that the fin should be approximately the size of this rectangle here, because if you build a teeny tiny little fin like that, of course, it's not going to do a whole lot. And if you look at the rockets that I showed you in the beginning, you can see it's about the size of that rectangle, okay? And doesn't have to be exactly that size, but you want it to be proportional to that size, okay? Real simple fins work great. One of my favorite, quite frankly, is just a simple right angle design. I like it for a lot of reasons, because it's really easy to draw. And of course, it's really easy to cut out. But if you want to add a little bit of style to it, you can do that. But whatever design your students want, I do discourage them from making anything too complicated, because then it gets really hard to cut out. And you'll see what I mean in just a second. Okay, that's the fin design I'm going with. So I just need a pair of scissors. And that's all we're going to really need in this step, and a pencil. And so I am just cutting this fin, and I'm going to use it as a pattern. This is not super complicated here. I'm just using this as a pattern for my fin. I like the little notch at the bottom. It adds a little style to the rocket fin. Okay, now I'm going to put this on here. This is very, very important. Make sure your students, 2 things they want to do. Make sure they start at the end of the material. Don't have them start with their fin right in the middle like this, because if they cut it right out of the middle, there won't be enough material to make 2 more fins. So make sure they start up at one end. And my fin has a straight side, so I take advantage of that fact and I go ahead and use the straight side of the fin material so I don't have to cut it there. I'm going to use a darker pen that shows up in video better, switch from this pencil. And so I just trace this pattern onto my fin material. Oops, that was a really bad trace job. Okay. Now, I'm going to cut this one out, and then I'm going to use this one as a pattern. Because just like you saw there, maybe I didn't cut it really, or draw it really well, or cut it out on paper really well. So I'm going to cut a fin out. This stuff is really durable, okay? Yeah, it could actually be a fin, but okay, that's just a scrap. This stuff is kind of hard to cut. Some of your students might have some hand strength issues with cutting it, but I always keep my scissors sharp. I have a scissor sharpener, and also remind the kids the scissors cut best down near the fulcrum, not out at the tip. If they try to cut with the tip like that, not a whole lot happens. Remind them to get down near the fulcrum. They have a lot more leverage that way. It cuts a lot better. And there we go, fin number 1. And then all I do is then I take that fin, I can discard that piece of paper. It's kind of hard to use as a stencil anyway, because it's so thin and flops around. And I'm going to use the fin I just created. And it's a lot easier to use it as a stencil, as a template, whatever you want to call it. And there's fin number 2. And then I'm going to squeeze this on here. That's okay. I got it. And you get the idea, but kind of a tight fit here, isn't it? That's okay. And there. All right. And then I'm going to cut out those fins. I'm going to pause the video. That'd be pretty boring to watch, so I'll be back in a second. Okay, I'm back, and I have all 3 fins cut out. I'm just going to stack them up here, see how good I did. And they're certainly not identical, but they are extremely similar, and similar enough that they will work just fine. All right. Another little thing you might want to do is sometimes cutting these things, they get some kind of rough, fuzzy edges. With the Pitsco kit, a piece of sandpaper comes, but I'm sure most of you have sandpaper lying around. And I just do a really light sanding to the edges of the fins, just to get rid of that kind of fuzzy edge there. So we have really good laminar airflow over all parts of our rocket that we possibly can. And if you have students that, want to make their fins absolutely perfect and struggle over the fact that they are slightly different, just encourage them and say, look, they're fine. If they're that close, it's fine. But, you always have some students that really are going for perfection, and the slightest little deviation kind of is very distracting to them. All right, so there are my fins, okay? And this is my straight edge. You can actually, I could use either edge. I think I actually had a design and intended to use this side, but no big deal, okay? Now we're ready to attach them to the bottle, all right? Now attaching them to the bottle is kind of an interesting experience. And so here's the bottle that we're using. This is a 20-ounce bottle. And you cannot use any old bottle. You cannot use a bottle like one of the Strato blaster kits does not provide the bottles, and you provide your own bottle, okay? Now, please hear me when I say this. Oops, and I'm upside down. Okay, you cannot use any old bottle. You can supply your own bottle, but you must supply a bottle that is designed to hold carbonated beverages, okay? An ordinary water bottle is not okay to use. Let me show you what I mean, okay? These 2 bottles look very, very similar, don't they, okay? But this bottle you cannot use for a rocket. It is not rated for carbonated beverages. and you're going to pressurize this thing to 65 psi, okay? And it has a risk of exploding. You cannot hold my come on, auto focus. Goodness gracious. There we go. You cannot use a water bottle. You can only use a bottle that is designed to hold, gosh, focus, is designed to hold carbonated beverages like this Coke bottle, okay? Reason is, I mean, obviously carbonated beverages have the potential of building up tons of pressure in the bottle. These bottles are designed, I believe they're actually rated at almost 150 psi, okay? Don't quote me on that, but it's a lot more than 65 psi. That is what our launcher operates at. Do not use water bottles, even though these are very, very common, probably more so than these. Do not, okay? Had to say that. That's my my PSA for safety. No water bottles, carbonated only. These come with the kit, so I use them, and you can tell they are really quite sturdy, all right? Now, before we put the fins on the bottle, because we're going to be pressing these fins on, notice the bottle kind of caves in when we do that, okay? So we pressurize the bottle, and we pressurize it with this little device you can get at any grocery store. It does not come with the Pitsco kit. This is a tool that you would need to supply separately. And we do it to pressurize the bottle so that when we are pushing this fin on here, it doesn't dent in like that. You can't even hear it. Oh, by the way, there's some background noise here. I have two 3D printers running just over my left shoulder. Sorry about that. All right, so we need to pressurize this bottle. So we are pumping this bottle up, and you can see it's has no pressure in it at all. And you don't have to go crazy with pumping up the bottle. You want to pump it up until it feels like a bike tire. You know when you squeeze a bike tire, and you can tell just by squeezing it, the bike tire has got proper inflation. That's what we're looking for, okay? And maybe it's like 10, 15 pumps. And now, there we go. When I squeeze that thing is resisting me, okay? It is not collapsing like it was before. And if I try to push this fin on here and hold it on there really tight, notice the bottle is not collapsing. That is very important, okay? Because if you don't hold this fin on here with pressure, okay, it probably will not hold through launch. It will fall off. The other thing is too, believe it or not, you can't see it, but the pressurized bottle expands slightly, okay? You can't really see it with the human eye, but it does, all right? And I've actually put a caliper on these things, and they expand about a couple of millimeters. You can't really see it, but they do. So what happens is if this bottle wasn't pressurized and you put your fin on there, glued your fin on it, and then you pressurize the bottle is going to expand and the fin just goes pop and it pops off. And if your fins pop off of your rocket, they don't fly well at all. I apologize. My autofocus is being really fussy today. But I'm trying to get it back into focus whenever it does that. My apologies. Okay, so we got our bottle pressurized. We got a pressure rated bottle, one rated for carbonated drinks. Now, this is a device here. If you don't have one of these, you can actually make one of these. And the Strato kit does not come with this either, but the boxes that the kits come in, they show you how to make one of these out of the cardboard box. I love these. I bought these years ago. They're kind of pricey, but over time I've accumulated enough for practically the whole class, okay? And these do two things, okay? Oh, by the way, I do not own stock in Pitsco. I'm just telling you what I know works really well. I swear, I don't know stock in Pitsco, all right? But we got these from Pitsco. They are wonderful, all right? Now, these do two things. The first thing we're going to use them for is when we put our pressurized bottle in there like that, notice these little signs on here that say fin this side. These plastic dividers are, of course, symmetrically spaced out around this rocket because we need to get lines on our rocket, okay? 3 lines on our rocket that are perfectly straight with the center axis of the rocket and also spaced exactly around the rocket for 3 fins. And this jig here does that trick very, very well. You don't have to do this. There are the ways to do it. You can actually measure it with a tape measure. You can calculate the circumference of the rocket, put a tape measure around it, do it that way. But boy, this sure makes it easy. So whatever method you want to use, here at Hayfield and other schools I've taught, we have always used this. So we use this jig to draw a line with a Sharpie around the bottle. This video primarily is for my students at Hayfield. So I'm going to be showing them with the tools and materials that they'll be using, all right? So if you can see that, maybe not against my black shirt very well, but there are 3 black lines on this bottle. You probably can't see them at all, but there really are, trust me, okay? Now we're ready to glue the fins on the rocket. However, these bottles, these particular bottles, are extremely smooth. Almost any brand new plastic bottle you buy will be extremely smooth. So the glue, the hot glue, will not stick to these very well. So we take some sandpaper and we scratch it up. We do not sand it, we just want to scratch it up. So you really just like this, back and forth a couple of times, and you create this hazy section right here. Come on, focus. There we go. You create this, and you'll feel it. It's scratched up. Do not let the kids go sand, 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 sand. We're not sanding a CO2 car. We are simply scratching the bottle. And I'm pressing hard and going slow, and I want to scratch it up. Only where the lines are, where my fins are going to go. I don't want to scratch up the rest of the bottle. That will definitely reduce my, or that will increase my drag if I scratch up the whole bottle, okay? So now I have the 3 lines I put on here. They're equal distant around the bottle. They're perfectly straight with the center axis of the bottle. They are scratched up, and the bottle is pressurized. Now I'm ready to put my fins on there. Let's talk about a glue gun for a minute, okay? It is very important that you use a low temperature glue gun. Now this is a Stanley glue gun, and I don't own stock in them either. Has a high setting and a low setting. It's important that you use a glue gun that has a low setting. On the high setting, the hot glue can melt the bottle. At the very least, it frequently deforms the bottle. It makes it all ripply and everything. You do not want the high heat glue guns. So I use a dual temperature glue guns, has high and low. I keep it on low, okay? Of course, also, it's much safer too. If a student gets the glue on their hands that's on a low temperature glue gun, yeah, it's gonna hurt, but it's not gonna injure, okay? It's gonna hurt, but probably not injure. On high, it will definitely injure. No ifs, ands, or buts about it, okay? Low temperature glue guns. And I use, of course, low temperature glue, okay? Another, I guess, safety tip and productivity tip too, because the high temp will melt the bottles. So I decide which way I want my fins to be on the rocket, and I think I want them like that, okay? You can actually work either way since both edges are straight. Now I'm going to put a bead, I'm going to put a healthy bead of glue, and this glue gun has been heating up for, well, since the beginning of this video, which is probably like, you're thinking, this video is way too long. Well, yeah, maybe it is, but you need to hear this, all right? And I'm going to put it right on that line, and it can't take a lot of time or the glue will start to cool and solidify. I'm going to make sure it's right on that line, and then I am going to press. I'm going to put pressure on this fin. All glue works better under pressure. We know that, right? Because you've heard me say it 100 times in class. All glue, come on, focus. Oh, I'm so sorry. All glue works better under pressure. I'm pushing that thing. And after about a minute, you can let go. And now, just leave it alone, okay? Just leave this fin alone. I did not do the best job in putting it on really, really straight on that line. Got distracted with this autofocus, but yeah, excuses, I know. And let's see, yep, I'm gonna put it on like so. No, yeah, like that. Again, I'm gonna put a healthy bead of glue, really healthy bead of glue on the edge of here. It's kind of blobbing it on there, if you can see how much glue I put in there. And again, right on the black line and the same distance top to bottom as the first fin. And I'm going to put it right on that line this time. Try to be better than I was the first time. And hold it on there. And I am pushing, and I'm pushing pretty hard. All right? It's really important. You want that pressure. Because when these rockets take off, they go from 0 to about 100 miles an hour instantaneously. I mean, just, it's an explosive acceleration. Explosive doesn't mean blowing things up. In the engineering world, what it means is a rapid exchange of energy. It's an explosive exchange of energy, or a rapid release of energy, okay? And then I'm doing my third fin, and I'm sure y'all got the idea by now. Blob the glue on there pretty good. These things will be under a lot of force. Come on, glue stick. There we go. And again, I'm going to put it right on that line, even with the other fins, not way up here, not way down here. And I'm pushing, and I'm going to hold it, I don't know, 30 seconds, minute or so. And you don't want to be distracted. You need to hold it nice and straight, okay? Because if you start looking around the room and chit-chatting with your friends, get distracted, okay? And if you've kind of globbed up the glue like I have on this side right here, do not worry about it right now, okay? Now, this glue has cooled off enough to where it is holding the fins in place, okay? But it's really not cooled off at room temperature yet. So if I were to play around with these fins and start moving them around, I could pull them off the rocket, and then I'd kind of be starting all over again. And I don't want to do that, okay? I keep holding my hand up to try to get autofocus to work again. Maybe it's better if I just lock focus. See if that works better. Yeah, I think that's better. Should have done that in the beginning. Sorry. I'll probably redo this video. Okay, so we're going to leave this alone for a few minutes. We're going to set it to the side. You can completely build this rocket in one class, teachers. You really can. So for your pacing guide, depends how many students you have, and it depends how ready you are. If you have a big enough lab where you can lay out all the materials, lay out all the tools, and all the students have all the tools, like if you have, I don't have glue guns for everybody, but I have glue guns for like half the class. The rocket stands, again, I have for about half the class. My classes are 31 students, okay? So, I can move things along pretty good, okay? Let's talk about this transition cone, okay? We're going to build the transition cone while that glue on those fins is cooling off and really setting up really hard, okay? We're going to build that. And with the kit, it comes for you already. You don't have to figure this out. Now, one little thing, see this dotted line right here? Do not cut on the dotted line. Students need to cut on the outside line of this. They want to cut precisely, but do not cut that dotted line. That is the overlap tab, where this end and this end are going to overlap, so you can tape this cone shut. See that tape right there? No, you don't, because it's exactly the same as the cone, okay? But it's that overlap tab that you're going to use to line this cone up. So I'm going to cut this out very, very carefully. Again, I'm going to pause the video because watching Mr. B cut paper probably isn't very exciting. On second thought, I just was recalling all the times I've had students cut this paper improperly. So yeah, I'm going to go ahead and demonstrate it, all right? It's pretty simple, and the glare is not good. Maybe I have to reset this. Yeah, the glare is really bad. What can I do about that? Let me unlock. There we go. Unlock focus, lock it again. There we go. That's what it looks like. There's that dotted line I was talking about, okay? And we're going to cut around the outside of this cone. So, right around the outside. And you want to cut accurately. This is a rocket, right? Rockets have to be built very precisely because they fly very, very fast. They're under surprisingly amounts of load. So I'm cutting very carefully on the outer line. I'm not cutting that dotted line. All right. There we go. All right. So that is what we want with that dotted line, because when we make the cone, we roll it up like that so that this end, the one end, lines up exactly with that dotted line. It has to be exact. This is a very precise fit. See this cone here? There is like no gap around the tube at all, okay? And when you put this thing on, especially for the first time, look at what a precise fit it is, okay? And also look at what a precise fit it is around the bottom. So you can't just kind of roll this thing up into a cone shape. You need to wrap it up so the one end of this pattern lines up exactly with that dotted line, okay? So here I am doing that. I'm taking it and I'm making sure this end here lines up, and let me flip it around so it's like how you're going to be looking at it. This edge here lines up exactly with that dotted line, not just close, but I mean exactly. And I don't know how many times I have to say that word to get students to know that I actually mean it, okay? It's right on there. If you don't do that, it won't fit. It will not fit on your rocket. It's plain and simple. It just won't work. And I put a little piece of tape, once I have it lined up perfectly, I put one piece of tape on there to hold it in place. And now I'm going to put a long piece of tape that goes top to bottom and even a little bit further. And then I tuck the ends of the tape inside. I'll show you what I mean by that right now. All right. So I'm going to make a piece of tape that's longer than the cone. I'm going to tape that entire seam nice and smooth. Because smooth means better aerodynamics. Now that wasn't great, Mr. B, but not terrible. And then I actually tuck this tag in because it also is holding the cone on the inside of the cone a little bit too. All right. Now I put it right on that dotted line, not close. Okay. I've seen people, do cones that don't even closely resemble a cone. Okay. And so now we're going to set this to the side. I am going to take a break here and I'm going to clean up a little bit. We have our fins on our bottle. We have our cone made, and I'm going to clean up a little bit here and do the next step in assembly. Okay, I'm back. Notice I don't have any tools out here anymore except for the glue gun, because that's all I'm going to need going forward. I do have this jig, love the jig, and you'll see why in a second, okay? I have my bottle with the fins on there, and that glue has really set up, and one way you can tell is it is starting to get cloudy, okay? When hot glue is cold, it is cloudy. When it's heated up, it's very clear. Now, it won't ever go back to as cloudy as it was before it was heated up, but it does get cloudy, and then you can just feel it too. And these fins should really be on there. You should be able to kind of test them a little bit, all right? And they need to really be on there. I have some excess drips on there as a little overly generous with the glue, but that's okay, okay? And I'll show you why in a couple of minutes, all right? We're just going to leave that alone. Now, the other thing, tilt this up a little bit. Again, oops, we're upside down. The other thing this jig does for us is it allows us to align this body tube perfectly with this bottle, which is really hard to do without some kind of a jig. Again, you can make your own out of really like kind of a small box, like a box of CO2 cars come in. But in the Strato Blaster kit, the other kit, this is the bolt kit. It comes with a box and they show you how to do that. There's actually a video by Mr. Zune, I'm sure, or Dr. Zune, sorry, that will show you how to do that. Anyway, I'm going to use this because this is what we use at Hayfield. All right, so I'm putting this bottle, it's still pressurized and everything. Doesn't have to be. And so if you don't have enough of these and some student goes, hey, I need a pump because I need to put my fins on, it is totally okay for this student to go, hey, here's a fin. Here's a pump, and hand it to another student, all right? But your student for putting the body tube on is going to need this jig. Now, I slide it in the jig, okay? I want you to notice something here. Notice inside of this jig, do you see that screw right here? Okay? There's a metal screw sticking out there. That is a spacer, and it's very important. When you put the bottle in, you want the bottom of the bottle to touch that screw. Now, the bottom of the bottle on this bottle has protruding part and it has concave part. You want the screw to hit on the protruding part, because if it does that, it'll leave the perfect little gap that we need. It's about a 1-inch gap. If you turn it such that the screw goes into the protruding part, there is no gap there at all. That is bad. That will not work for you. So take your bottle, turn it so that the bottom of your bottle is hitting that screw, and you have about a 1-inch gap. Now, notice the holes in this jig right here. This is where our body tube goes in. Do not just shove it straight in like that, because it is a very precise fit. So I'm actually going to twist it, almost if you're like putting a screw in a piece of wood, you kind of twist it to go in. And I'm going to twist it until it makes total contact with our bottle, okay? Total contact, all right? And you'll see why we need that gap there right now, because we're going to put a bunch of glue in there. And we hold the rocket in the orientation like it is flying. We hold it straight up and down like this, because when we squirt the glue in there, we're going to squirt the glue in the gap right on the end of that cardboard tube, and it's going to drip down. There we go. So you can see that. It's going to drip down that cardboard tube onto the bottle. Gravity is doing our work for us. Can you see that? It has dripped down to the plastic bottle. And then we just rotate the whole jig, and we're going to squirt it in there. Let me see, it's on camera. There we go, like that. I'm squirting it on just the last 1/2 inch of the cardboard tube. And I'm holding it upright, like the way our rocket's going to fly, so that the glue will drip down onto the plastic bottle, which is exactly what it's doing. And then go around to the third side and do exactly the same thing. Now, what always have a couple of students do, and teachers really be on the lookout for this, students will shove this bottle in there. They will not pay attention to that gap or that screw. And there will be a gap of about, just a 1/8 of an inch. And they will squirt glue in between this jig and the bottle. And of course, what happens, the bottle becomes glued to the jig, okay? Makes a big mess. When that happens, what I usually end up having to do is have to get out my heat gun and heat the glue up so it will release from the jig. And then the student has to start all over again because they have a great big mess. Okay, that's a lot of glue, all right? That is going to take, I leave it alone for 5 minutes, okay? That connection is critical. It's very good right now. I held the bottle up the way it's going to fly. I squirted glue in just on the bottom part of that cardboard tube. I let it run down onto the bottle, and I did that 3 times all the way around in that little gap there that I have where I can get the glue in. And now I'm going to set this down. Watch out for your fins. I always hang it off the edge like that. And I'm going to leave it alone for 5 minutes because that's a lot of glue and it will stay pliable for a long time. So this is a good opportunity to just go ahead and set your rocket to the side for 5 minutes or so. And really just not do anything else for 5 minutes. Chit chat with your neighbor, all right? Okay, I'm back, and it's been about 5 minutes or so, and this glue is almost room temperature to the touch, so it's not 100% cured, but it's pretty good. The longer you wait, the better. So how do I get this rocket out of this jig? Remember what a precise fit it was when you put this body tube in this jig? Well, let me tell you something. If you grab, do not do what I'm about to do. Do not, but you're going to want to do it. Don't do it. You grab the bottle like this and pull on it, you're going to pull it right off that tube. I guarantee you, okay? 90% of the time, you pull it right off that tube. And then you've got a huge mess. You've got a bunch of glue on your bottle. You got a bunch of glue on the tube. You got to do it all over again, peel off the old glue. It's a mess. You don't want to go there. But there is a super safe and easy way to do it, all right? Here's how we do it. I'm pointing the rocket down. I'm pointing the camera down, and I do not pull on the bottle ever, ever. I go like this, and I push straight down. I push the jig straight down, and it slides the tube out of the jig, and then I just use my thumb to get the last part slid out. And notice at no time am I grabbing the bottle and yanking on it. Okay, I am only pulling on the tube, and there we go. My rocket is out of the jig and unharmed. All right, yay. Okay, so here we go. All right, here we go. Rocket looks pretty close to done, right? Well, it's because it is. We take that transition cone we built earlier. Remember I told you, you've got to line the edge up exactly with that dotted line. Look what a precise fit it is. If it was any smaller, it would not fit. If it was any bigger, it would have a big air gap here, and when it flew, it would create all sorts of drag. But that is a beautiful thing. That is a beautiful rocket. The last thing that we have to do is the recovery system, okay? And I'm going to show you how to do that in just 1 second. So here we go. The first time I saw this, I said, that is the oddest recovery system for a rocket I've ever seen. It is a ping pong ball, a cup, and they're attached together by a little string. And I said, how can that possibly work? And well, it actually does. Nope, wrong way. All right. It actually does work. And the way it works is as the rocket goes up, this ping pong ball acts as a really good nose cone, okay? It's really, really great at deflecting the air around the body tube and around the rocket. It's very, very effective. But when it gets to the very top, okay, it gets to what we call the apogee, the very highest point in its ballistic flight, the ping pong ball falls out. And now the ping pong is not helping with aerodynamics at all. Matter of fact, it is making aerodynamics really bad, all right? Because if the rocket tries to nosedive, this opening in this yellow cup is going to catch all sorts of air, okay? And also the ping pong ball is just kind of out here flopping around, catching a lot of air too. So it ends up causing the rocket, instead of to come down like what we call lawn dart fashion, all right, it's so much drag up at the nose of this rocket, the rocket just kind of comes down sideways, all right, in a very non-aerodynamic profile. As a result, it comes down really slow. And you can literally run out there in the landing zone and catch it, okay? Because it goes up really, really fast. It gets to the top, the ping pong ball falls over. Your rocket now has horrible aerodynamics, and it just comes wobbling down pretty horizontal like this. Sometimes the ping pong ball can get wrapped around this tube, all right? It doesn't happen very often, but it does happen. If it gets wrapped around the tube, your rocket can come down lawn dart, okay? And you don't want to go and try and catch it because it's coming down fast enough to where if you stuck your hand out there and hit it, it'd leave a mark, all right? So, but we'll talk about that later when we're getting it to launch. I just put my rocket in the holder right here. Okay, we have a stand for it. Looks like that. Okay. Now, how do we build this thing? Well, it's simple, but frustrating at the same time. All right. I'm going to try to get real close here because we're fooling around with a teeny little string. All right. So we take this cup. All right. It has a little hole in the bottom. And this is the first frustrating part. We have to take our string and we have to feed it through the little hole in the bottom of the cup because we need this string to be on the inside of the cup. If it were on the outside of the cup, it would be exposed to all the high-speed wind that's going to occur when this rocket takes off, and it could actually pull the ping pong ball out of the cup. So you're going to pull it through until you have just a little bit of string like that sticking out. See that? I know it's kind of hard to see, but you just have a little bit of string sticking out. I mean, like half an inch, all right? Now what happens, and I've done it too, is I let go of that string and it falls through the cup. Well, just do it again. And then once you have it like this with just a little tag end sticking out, you put just a little dab of glue, just a little bit. Set it upside down and wait until it cools off. Honestly, don't try to do anything else with it. Just wait. About 2 minutes. Okay, I'm back. This is cooled off and that string is nice and secure in there. It's not going to go anywhere. You take the other end of the string, and this is the part that's frustrating because the ball likes to roll around, all right? And sometimes people will like try to put the ball in the cup and get the ball to stay there. Whatever works for you, okay? And you want to take just the very end of the string here and glue it to the ping pong ball. It's very important you do not put a ton of glue here. And I'll explain why while this is cooling. See that drop there? Maybe a little bit more than a drop, but you get the idea. It's not a big wad of glue, okay? And now I can let this sit here, and I'm going to let that cool off. It's going to take a couple minutes to cool off. But the reason, okay, you can't have a big wad of glue is it needs to be a small amount of glue so that it will fit in that cup, all right? Sometimes students put a whole bunch of glue on there. Whoops, I'm upside down again. That's pretty funny. You just need a little bit of glue there because the ping pong ball needs to sit very flush in this cup. Got to get all this string in this cup because if it's outside of the cup, when you launch, seriously, these rockets go over 100 miles an hour. All right, I got the string all tucked in there, and the ping pong ball is setting really nicely, setting down in that cup. All right. If you have a big wad of glue on the bottom of that ping pong ball, it will not set nice and neatly in that cup. All right. And it will fall off during flight. So here's an example of a ping pong ball where somebody put a ton of glue to hold that string on there. Can you see that? Maybe I need to here, reset. All right. A ton of glue to hold that string on. Here's what I was talking about. If I try to put this ping pong ball in the cup, see how it will not sit in the cup properly? Compare the two. Okay? This is sitting on top of the cup. There's a big gap there, all right? And there is really no way except to put it on here and expose the glue, expose the string, which is going to cause the ping pong ball to fall out of the cup. If I try to put it with string side down, I've got this huge gap because of this ton of glue here. See, it's not sitting in there. And when it takes off, the ball is going to fall out. If your ball falls out during launch, your rocket will go about 5 feet in the air, maybe 10 on a good day, okay? The aerodynamics are wrecked, absolutely wrecked if that ping pong ball falls out. So I'm taking this ping pong ball and I'm writing bad. No, don't do this. And somebody will do it, okay? I guarantee you. They will have a wad of glue on this thing because while they're trying to glue the string on, the string is moving around and they start chasing the string with the glue gun. Don't do that. If the string moves around, stop. Catch the string and pin it down with just a drop of glue, okay? So you don't want a wad like that. You want just a little dab will do it like that, okay? This will not work. Bad ping pong ball, all right? Go to your room. Okay, one very last thing, and I promise we're done. I know it's a long video, but we're building an entire rocket from scratch. We want to go through here, not that this glue has cooled off a lot, okay? We want to go through and reinforce these seams on these fins. It is a good idea to pressurize your rocket when you do that, okay? Now your rocket is done. You could fly it like it is, but I don't like to take chances with the fins because the fins are under so much pressure. Because as I'm inflating this bottle, the bottle is expanding and the fins are already under pressure and we haven't even launched this rocket, okay? So pump it up until it feels like a good inflated bicycle tire. If you pump like crazy on this thing and like, hey man, look how hard I can pump this up. I'm going to pump it up and pump it up. Here's what happens. It breaks. These things are $8.50 a piece. Anywhere from $7.50 to $8.50 a piece. They will break. Also, we will know you did it because you will pump it up. And even if it doesn't break, when you take the thing off, it's just a little hiss of air. It makes a big, loud hiss of air, almost sound like a balloon popping, and we know exactly what you did. So once you have done that and pumped this thing up, because you're trying to pump it up and see if you can make the bottle explode. Oh, that'd be smart. A bottle exploding in your hands and in your face, that would have a bad outcome, okay? Or trying to make the pump break, that's a bad outcome too, because you're going to owe me $8.50. We want to reinforce these fins, okay? Make sure it's pumped up like a nice inflated bike tile. And then I'm just going to take this and I'm going to run a quick bead down here. I'm not trying to put tons and tons of goop on here, right? I'm just running a quick bead down both sides of the fin. Because when I put it on here the first time and I just had a bead of glue on the edge of the fin, it's not perfect and it might have squeezed out in a couple of places and it really doesn't have very good coverage there anymore. And so I'm just going down, make sure I have really good coverage top to bottom. And I should have tilted that down a little bit so you can see what I'm doing. All right, let's reset that. That autofocus is just about making me crazy, isn't it? You too, I bet. And again, I'm running just a bead of glue right where the bottle and the fin meet on both sides. Just make sure I have a nice smooth, continuous seam there. All right. And now, yeah, you got to wait again. You got to leave it alone. And come on, get back into focus. Thank you. Lock. There we go. You want to let it cool off again, and you're good. Now, once you've done that reinforcing bead on there, you're going to leave the pump on just for a couple of minutes, okay? And then take it off and hear this. Just a little, that's all you should hear. If you hear a big shh or a pop, I know what you did, all right? And I don't appreciate it at all, all right? I'm done, okay? This rocket is complete, all right? And just kind of review what we did. We designed our fins, and we used that design sheet we had, and then we took that design, traced it out on the fin paper, on the fin material. We cut it out. Then we used our first fin to trace out fin number 2 and 3. Ended up with 3 fins. Then we got our bottle. We pressurized our bottle. We used our jig to put 3 lines evenly spaced around the bottle. Notice these plastic dividers have a little sign on them that says fin this side. So you want to put your plastic, your black line on the same side of those dividers so that they're evenly spaced. I get my lines on the bottle. I take a little sandpaper. I scratch those lines. I do not sand them. I scratch them. I press hard and go back and forth, maybe twice, okay? Scratch it up so the surface isn't super smooth so the glue sticks. And then I let it dry after I put my fins on. Oh, remember the bottle is pressurized the whole time I'm putting fins on it, and I leave it pressurized. So when you get one of these pumps, you're going to be holding on to this pump for about 10 minutes, maybe 15 minutes. I have quite a few pumps, but not enough for everybody because they do disappear and they do break. I think I have about 20, all right, which isn't too bad, okay? So while your fins are cooling off, you're going to go and you're going to cut out your transition cone. Remember to leave the dotted line because that is your overlap mark. Overlap it, tape it exactly on the dotted line, set it to the side. Then when you are ready, when your fins have cooled off, you're going to put your bottle back in this jig. You're going to slide the body tube into this jig so that it meets the bottle. You are going to make sure you leave a nice inch gap between the bottle and the body tube. If you don't do that, things don't go very well. You're going to glue it up. You'll take it out of there by pressing on the tube, not pulling on the bottle, okay? And you will have an almost finished rocket, and then you will make your recovery system, which is the nose cone and the yellow cup. And now you slide in your recovery system. You're done, okay? This is a very high performing rocket. You will be very pleased with how well they perform. They go from 0 to about 100 miles an hour instantaneously. And I've told this to students, and nobody ever believes me until they actually see it. The rockets fly so fast, for the first 20 or 30 feet, you can't see them unless you are standing back about 40 or 50 feet, and then you can see them. But if you're standing close to them, they fly faster than the human eye can actually see. All right? So there you go. I know that video is long enough, but hey, we just built a rocket start to finish. Have fun with this project, and boy, are we going to have fun when we launch it, all right? So I will see you soon. Have fun.